Hi, welcome to my channel. In this video, we want to find all non-negative real numbers w, x, y, and z such that w plus x squared plus y cubed plus z to the power of 4 equals 4 and w plus 2x plus 3y plus 4z equals 10. First, consider the equation w plus x squared plus y cubed plus z to the power of 4 equals 4. Subtracting 4 from both sides of the equation gives us w plus x squared plus y cubed plus z to the power of 4 minus 4 equals 0. Next, split minus 4 into minus 1, minus 1, minus 1, minus 1. And rewrite the equation as w minus 1 plus x squared minus 1 plus y cubed minus 1 plus z to the power of 4 minus 1 equals 0. Next, consider the equation w plus 2x plus 3y plus 4z equals 10. Subtracting 10 from both sides of the equation gives us w plus 2x plus 3y plus 4z minus 10 equals 0. Noting that 10 equals 1 plus 2 plus 3 plus 4, we split minus 10 into minus 1, minus 2, minus 3, minus 4. And rewrite the equation as w minus 1 plus 2x minus 2 plus 3y minus 3 plus 4z minus 4 equals 0. Following this, we call the top equation as equation 1 and the bottom equation as equation 2. Then subtract equation 2 from equation 1. W minus 1 cancels each other out, while x squared minus 1 minus 2x minus 2 gives us x squared plus 1 minus 2x. Y cubed minus 1 minus 3y minus 3 gives us y cubed plus 2 minus 3y. And z to the power of 4 minus 1 minus 4z minus 4 gives us z to the power of 4 plus 3 minus 4z. Therefore, the variables x, y, and z satisfy this particular equation. Next, consider the term x squared plus 1. Let's use the AMGM inequality to analyze this term. Given non-negative variables a1, a2 all the way to an, the AMGM inequality states that the arithmetic mean given by the sum of the variables divided by n is greater than or equal to the geometric mean given by the n root of the product of the variables, with equality if and only if all the variables are equal. Multiplying n to both sides of the inequality, we obtain the sum of the variables is greater than or equal to n times the n root of the product of the variables. For our case, n equals to a1 equals x squared and a2 equals 1. So we have x squared plus 1 is greater than or equal to 2 times square root of x squared times 1, with equality if and only if x squared equals 1. The right hand side of the inequality is 2x. Since x is non-negative, taking the square root of x squared equals 1 gives us x equals 1. Moving 2x to the other side, we obtain x squared plus 1 minus 2x is greater than or equal to 0, with equality if and only if x equals 1. Next, consider the term y cubed plus 2. Writing the expression as y cubed plus 1 and then applying the AMGM inequality, with n equals 3, a1 equals y cubed, a2 equals 1, and a3 equals 1, gives us y cubed plus 2 is greater than or equal to 3 times cube root of y cubed times 1 times 1, with equality if and only if y cubed equals 1. The right hand side of the inequality is 3y. Taking the cube root of y cubed equals 1 gives us y equals 1. Moving 3y to the other side, we obtain y cubed plus 2 minus 3y is greater than or equal to 0, with equality if and only if y equals 1. Lastly, consider the term z to the power of 4 plus 3. Writing the expression as z to the power of 4 plus 1 plus 1 plus 1, and then applying the AMGM inequality, with n equals 4, a1 equals z to the power of 4, a2 equals 1, a3 equals 1, and a4 equals 1, gives us z to the power of 4 plus 3 is greater than or equal to 4 times the fourth root of z to the power of 4 times 1 times 1 times 1, with equality if and only if z to the power of 4 equals 1. The right hand side of the inequality is 4z. Since z is non-negative, taking the fourth root of z to the power of 4 equals 1 gives us z equals 1. Moving 4z to the other side, we obtain z to the power of 4 plus 3 minus 4z is greater than or equal to 0, with equality if and only if z equals 1. After that, we add these inequalities to obtain x squared plus 1 minus 2x plus y cubed plus 2 minus 3y plus z to the power of 4 plus 3 minus 4z is greater than or equal to 0, with equality if and only if x equals y equals z equals 1. Since x, y, and z satisfy this equation, and we just showed that the left-hand side of the equation is greater than or equal to 0, and equals 0 if and only if x equals y equals z equals 1. We thus have x equals 1, y equals 1, and z equals 1. Recalling our original equations, and substituting x equals 1, y equals 1, z equals 1 into the equation, w plus x squared plus y cubed plus z to the power of 4 equals 4. We obtain w plus 1 squared plus 1 cubed plus 1 to the power of 4 equals 4. Solving for w gives us w equals 1. Therefore, the solution to our original equations is w equals 1, x equals 1, y equals 1, and z equals 1. As an exercise, try to solve this system of equations and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.